Okay. First of all, I want to talk about some question we did yesterday. There's a question I circled 2, 3, 7, 8 for you to do it, but I said example 5 is a really interesting question. That's maybe the most difficult type of question you may get for this exercise. We want to antidiff something, but the thing we're trying to let's just think about example 5. Example 5 says differentiate x times e to the power of minus x. Let's diff that first. Okay, that's question 5. d dx of xe minus x. Okay, that gives me e minus x minus xe minus x. Okay, because we have differentiate x first, we got 1. So we times 1 with e minus x, and then we diff e minus x, we got minus e minus x, and then times with x. So that's the answer we have here. And let's have a look at what we want. I want integral of 2x minus 5 bracket e to the power of minus x. This is not really looks like what we get for the differentiation. Okay, so my differentiation, like part of it, maybe this part, not this part, like part of it is really not looks like that one. Okay, so what we can do, so what is asking here may not really just coming from this part. So when you see bracket, when you time something together, we always think about expansion first, because you know we can't do something times something to do antidiff for method. Okay, so but we can expand it. Okay, we can expand it first, and then think about which part I know and which part I don't know. I can separate that to 2 antidiff. So that's 2x times e to the power of minus x minus 5e to the power of minus x. Okay, so I can expand it. Like this is what I want. Okay, I also know that equals to what. So this thing also equals to that. Okay, this also equals to that. Because it's a minus in between, I can just separate that as this. There's a dx as well. How many integral signs you have right? You need how many dx? So there's another dx. Okay, so what I can't diff is this part because the x, okay, because of the x. I can't antidiff that because it's something times something. But I can antidiff this part. This part will give me a plus 5e to the power of minus x. Well, I will plus c later. I haven't antidiffed this part yet. Okay, so what I want has simplified to this form. Okay, I have solved part of it. And now there's one part I don't know how to solve. Okay, I leave the part I don't know how to solve. And then we look back for part 1. So this is what I want. This part is contained in this one. Okay, it's contained here. So then what I can write is integral of e to the power of minus x dx. Well, I directly separate it. Integral xe to the power of minus x dx. That gives me xe to the power of minus x. Okay, antidiff the right-hand side, that will give me the left-hand side. Well, I just write into 2 separate differentiation. I know I will separate later. So again, I can solve part of it. Okay, I can solve part of it. I can solve this part. That gives me minus e minus x. Okay, I'll change this to left-hand side first. Minus e to the power of minus x. That equals to integral xe minus x dx. Okay, swap those two terms. Okay, swap those two terms. Move the integral to right-hand side and move the right-hand side value to the left-hand side. So now I have the equation for integral of xe minus x equals to something. Okay, that equals to something. So how many of that I need? I need 2 of that. Okay, I need 2 of that. So I will times that by 2. Integral 2xe minus x equals to minus 2e minus x minus 2xe to the power of minus x. Okay, times everything by 2 because I need 2 of that. Okay, I need 2 of that. So now I can put this answer back to here. Okay, so this part gives me minus 2e minus x minus 2xe minus x and plus 5e minus x is where originally you get. And that equals to 3e minus x minus 2xe minus x. Okay, so this is, well, you can see this question is harder than the question we have done before because only part of what you want needs to use that like integral by recognition method, but not all of it, okay, not the whole part. I can't just treat the whole part because you can see what I want on the right hand side is not some form given on the left hand side. So I need to adjust that or like change the like format to make it like the way I can, to make it like something I can work with. Whose late pass is that? No, I mean like who write that? No. Ran Auto's late pass?
I lost my card.
Oh, okay. Oh, it's only half here.
I had it yesterday, so
Oh,
I
okay.
don't actually know what happened.
Okay, so do you get this question here? Like this question is a really good one because it involves a lot of things here. So when you get a question in the exam, it might be like the whole part needs to use the integral by recognitions. Maybe only part of it need that. So you need to think about this as well. Okay, so that's the question we did yesterday. Just a little bit revision on that. Any questions about question 5? Okay. If we're fine with that, let's have a look at next page. Well, we finally back to exercise A. Okay, exercise A is the second use for integrations. The first that we use integrations to, we know f dash x, we find entity of it, and we can find the original function. So integral f dash x give me fx. That's the first way we can use integration. Well, we understand that better. That's why I changed the order. I put A after that. There's also another way we can use it. It's nothing to do with the gradient. Okay, it's nothing to do with the gradient function. It's completely a different thing. Okay, integration is a completely different thing in this exercise. So what we use to do with integrations. Let's not talk about integrations first. Let's talk about the area under the curve. Okay, let's just talk about the area under the curve. I think it's the next exercise, talk about integration. So A is the introduction. So what I want to do is approximate the area under the curve. I know if it's a straight line, I can find the area under the curve. It's a triangle shape. For example, it's a linear. Okay, I want to find this area. So it's a trapezium. I can use trapezium formula to find it if I know the equation for fx. But now let's think about if I have something like this. I want to find the area in between A and B, which is this area. Okay, which is this area. This is not the trapezium shape. Okay, it's with some curve on top. So I can't find the exact area yet. Okay, just from the knowledge we have. Now, like we can't find the area under the curve. So now we talk about a method to approximate the area. Is we draw small rectangles in the area and then calculate the rectangle's area to use that approximate area under the curve. So I make this larger. Okay, the actual area is the red bit like I have found, like that's the actual area. And in between A and B, I have sketched 1, 2, 3, 4, 5. I have sketched 5 rectangles. Well, I can sketch more, right? I can make the length like width shorter, like half of it. I can sketch 10 rectangles. I can sketch 100 if I make it like 10 small pieces. Well, like it's too hard to do that on the graph, so I just sketch 5. Okay, that's 5 rectangles. What's the difference between the actual area and the approximate area? What's the difference? Like, where is the difference? It's not exact. Like, the rectangle is not giving you the exact area. So, how much less or how much more? This bit, right? So, I use the blue color. So, is this part. Like this part is the part like I lose, like I haven't calculated, I haven't involved. But think about if I make more rectangles like in the same method. Here's see what method I use. I use like first of all I use this height, the height of A, okay, to draw with a length of this much, like a width of this much, to create one. And then from that point I draw another height, and then same length to create another rectangle. So I keep using this way until I touch to finish at the point B. If now I half the width, but use the same method to draw the rectangle, do you think I will got a more accurate answer or less accurate answer? More accurate, right? You will clear some of this blue bit. So for example, I just show you one. So if I draw another one, right? Like I have gained this much, which is eliminate the error as well. So if I do that for all the rectangles, half them, so you will gain some more things. But think about if I cut that into 10 small pieces, I will get even more accurate, right? So this is called a left-hand side rectangle approximation, or you can say left endpoint approximation. So I start to sketch my rectangle on the left-hand side with a particular width, okay? So they're all the same width. So this is one of the methods we use to approximate the area first. So we call that the left endpoint estimation or left rectangle estimation. Why I call that a left endpoint? Because I start my first rectangle by using the left hand side point as the height. Okay, so I use A as the height. Can you see on my right hand side, this length hasn't been used. This length, I haven't used that length at all. Okay, so I only use all the left hand side. I take the left hand side height as my rectangle's height, and then I still create another one. But the most right hand side point, that height, I haven't used it at all. So therefore, we will have the right hand side approximation as well. Okay, why I call that a right hand side? I start to draw the rectangle on the right hand side. Still 5 rectangles, exactly the same graph. 5 rectangles in between A and B. But I start to sketch my rectangle by using the most right hand side point to sketch. Okay, so this is my first one. Now I reach this point. I will use this height as my new rectangle. So I have this one. Now I reach this point. I use this height to draw it. So what you can realize is this height hasn't been used at all. The most left-hand side point hasn't been used. Yes? This is the difference between a left-hand side rectangle and right-hand side rectangle. But what you can see here is this area is overestimate, right? They all go above because this is an increasing graph. You use the right-hand side point, then the graph will be all over the height. Like you use the right hand side, so from here to here, the height is more than what it actually should be. But if you use left hand side approximation, it's all underestimate. Okay, it's all underestimate. So from the same graph, you're trying to use different way to approximate that. You will have different answer, and one will be overestimate and one will be underestimate. Can you tell me if I have a graph like this and I want to find the area in between A to B. Okay, I want to find this area. If I use left endpoint estimation, will the approximate area be underestimate or overestimate? Over, right? Overestimate, because say doing that. Okay, that's the left hand side. That's how you sketch it. Okay, so they overestimate. This is left-hand side approximation. That is left-hand side approximation as well. But one is overestimate, one is underestimate. Why? Why use the same method to approximate? Why one over, one under? Decreasing function, increasing function. Okay, it depends on whether it's decreasing or increasing function. If it's decreasing, then you use left-hand side point. That's a larger height, okay, compared to the actual height. So it's a larger height. But if it's an increasing function, use the left-hand side. It's all below the actual height. So it's underestimate. So same thing will happen here. If I have the same graph here. Okay, same graph here. Okay, I want to estimate the area in between A and B again. If I use right-hand side approximation, I start to draw rectangles on the right-hand side. Okay, which is this one. Now I need to increase the height, which I draw this one. Now I use this height to draw the next one. And then we use this to draw this one. So I just create 4. This is underestimate. Okay, right-hand side approximation for both diagrams, but one underestimate and one overestimate. So it depends on whether it's increasing function or decreasing function. So something we need to know is here. For f increasing over a to b, for f decreasing over a to b, well, it's only talk about only increasing in between A and B and only decreasing in A and B. So the true area will be larger than the left-hand side rectangle and will be smaller than the right-hand side rectangle. So let's say an increasing function. This is the increasing function. Okay? This is the increasing function. This is the left-hand side approximation. This is the right-hand side approximation. And this is the actual area. Okay? The relationship is that this is smaller than actual. Actual is smaller than the right-hand side approximation. But let's have a look at the decreasing function. The actual area is here. Decreasing function. Actual area is smaller than the left-hand side approximation and is larger than the right-hand side approximation. That's how we can see the relationship between that. Well, you don't need to really memorize it. Well, it's too hard to memorize. You can just sketch a diagram and you draw the left-hand side approximation and right-hand side approximation to see what you should get. Okay? Now, let's just have a look at the example 6. Let's really calculate how to calculate the approximate area. So the area under the curve y equals to log ex. Okay, I have sketched log ex. I have 1, 2, 3, and 4. Between 1 and 4. Okay, so between 1, I can't sketch 1. That's 1 to 4. Okay, is approximate by 2 shaded rectangles shown above. The approximation area in square units is, okay, first of all, can you tell me there's a left-hand side approximation or right-hand side approximation? Left. Okay. To say it only got 2 rectangles, I actually should say it got 3 rectangles. Okay, in between 1 and 4, it has been divided into 3 parts. Okay, 1 to 2, 2 to 3, and 3 to 4. But what happens to the first rectangle? 1 to 2 rectangle is just a 0. Okay, that's actually my first rectangle. Because I used the left-hand side height as the first height, but that height is 0. When x equals to 1, y equals to 0. That's why you don't have the first rectangle. You actually cut the area into 3 partitions and you actually calculate 3 area instead of 2 area. But the first area is a 0. That's why it's still a left-hand side approximation. You should got 3 rectangles, but only you can see 2 here. So, well, the first height here. Okay, I just show you the formula. The first one here, I will say that's a log E2 plus log E3 times 1. Okay, that's the formula we should have. This height is log E2. This height is log E3. you know you sub the x value into the function, you get the y value. So all the y values sub together times the width. Okay, you have a common width which is 1 for all the rectangles. So this will give you log E6. Okay, this will give you log E6. This one's easy. Let's have a look at the next one. Next one already sketched the rectangles for you. Is this a left-hand side approximation or right-hand side approximation? Left, right? Left. But because there's no function given, but instead the height is given. What's the width? Width is 1, right? 1 to 2, 2 to 3. The width is 1. Width is not always 1, okay? Width can be 0.5, even can be 0.1, even can be 0.01. Like, it depends on how many rectangles you want to sketch. For example, in between 1 and 5, there are 4 units. I can draw 4 rectangles. I can draw 8. I can draw 16. Like, it depends on how many, what's the width I want to make. So, therefore, I will go for, okay, the first one with a height of 4, plus a 7, plus a 12, plus a 19, times 1. Okay, so we got 42. Okay. Look at B. What kind of approximation is that? Left or right? It's nothing. It's not left or right. Can you see that? If it's left, okay, if it's left, the first one still stay like that. The second one is good enough. But start from the third one, you should have this. And the fourth one still stay like that. But this bit shouldn't belong to the left-hand side approximation. You shouldn't have that part. So it's not really a left or a right. It's just like, you know, like if I use left or right, it looks like it's not good at all. Like it's not an increasing function or decreasing function. So it's a random shape. So they're trying to make rectangles looks quite similar to the actual area. Otherwise, can you see if I lose that bit, it's not accurate at all. Like we lose quite a lot of part, like a lot of area there. So they're trying to, by inspection, they see, okay, that rectangle maybe works better. So they just create another rectangle, not using left-hand side or right-hand side approximation. But this will be given. If ask you this type of question, it will giving you the graph. It's not asking you to sketch it. If the question asks you to approximate, they can only be left-hand side or right-hand side. So this one you have 7 plus 5 plus 7 plus 7. And then that's still times by 1. 26. Okay. Example 8. For example 8, can you sketch 9 minus x squared first? Okay, sketch 9 minus x squared first. If you have space, sketch 2 of that. Better sketch it with the same scale. I'll show you, you don't need to sketch it later if it's asking you left hand side or right hand side approximation, but I want you to show you the graph first. Later when you do this type of question, you don't need to sketch it at all. And also be careful, use interval of width 1 unit. That's really important. Sometimes they'll say use a width of a half unit. They can only ask you 1 or half. Okay, so 1 unit or half unit. Be careful with that. My left hand side approximation. This is my right hand side approximation. Just compare the shape. You can see the shape. I have 5 rectangles in the first one, but only got 4 rectangles in the second one. Why we only got 4 rectangles in the second one? It's 0. Okay, so the most right hand side point got a height of 0. So the blue line here, which means I got a rectangle there. It's actually a rectangle with length, with 0, height 0. So, okay, now what I said is important. You don't need to sketch diagram every time. Like it's too slow to sketch diagram every time to find the approximation. If I can write about the equations, I will get for A. A is a left-hand side approximation. Okay, what's the formula should be? The formula should be f negative 2, well, the height, plus f negative 1, plus f0, plus f1, plus f2, times by 1. Okay, so this height, this height, this height, this height, this height. Okay, 4, 5 height. Okay, 1, 2, 3, 4, 5. 5 height. Okay, can you see we have from negative 2 to 3. I use left hand side approximation. my value include -2, -1, 0, 1, 2, but not 3. Okay, that's the right hand side approximation because I'm not using the right hand side point at all, so I don't have F3. Okay, so if I can calculate that, that will give me 5 plus 8 plus 9 plus 8 plus 5 times 1. That's a 35. But if you think about B will be go right hand side, F3 plus F2 plus F1 plus F0 plus F -1. Still have 5 values, but you have the most right hand side point, but not the most left hand side point. Okay, that's why I said you don't need to sketch a graph at all. You just need to start from left or right. And x value increase by the interval width. Okay, the interval width is 1. So 3 go to 2, 2 go to 1, 1 go to 0, 0 go to -1. But I'm not using -2 because it's a right hand side approximation. So that gives me 0 plus 5 plus 8 plus 9 plus 8 times 1. That's a 30. Okay, because we just lose one rectangle. Okay, we just lose one rectangles. And C is find the average. That's easy. 30 plus 35 over 2. Okay, so you don't need to sketch the diagram. You start from which side they required, and each x value will increase by the interval width. Okay, so 1 or 0.5. Okay, 1 or 0.5. Also, you can see from -2 to 3, that's 5 units, and each rectangle is 1 unit. So you should have 5 values. Okay, you can count. You can count. You should have 5 values. 1, 2, 3, 4, 5. You can't add another one. That's 6. Okay, that's the 6th one. So you can't add another one. So 5. Okay, 5 each side. Okay. When we know this, can we just have a look at example 10? I don't really need you to calculate this out, but I want you to think about it. So find the left endpoint and right endpoint estimates of the area under the curve with this equation. Okay, fx equation is given, and 4x belongs to 2 to 6. How many units are there? How many units? Like, what's the length in between 2 to 6? 3, 4, 5. Choose one. Length 2 to 6. 3, 4, 5. How many? 4. Okay, 4. 2 to 3. 3 to 4. 4 to 5. 5 to 6. 4. Okay, that's 4. Using 8 partitions. 8. Then what's the width? What's the interval width? I have 4 units, but I want to divide into 8 pieces. What's the width? Half. Okay, 0.5. 4 divided by 8. So each step should be a 0.5. So what I should know, the interval width is 0.5, or say half. Now use my method. Left endpoint. That should give you, well, I start from the left. So it should be F2. But the next point can't be F3 because it's 0.5 partition, so we'll 0.5 intervals. So next one should be 2.5. And then the next one will be 3. And 3.5. And 4. And 4.5. And then 5. And 5.5. Not finished. I can't times 1 now because each width is a half. So I need to times that by a half. Okay, can you think about that? Without sketching the graph, you should be able to write this out. I'm not going to use the most right hand side point. I have 1, 2, 3, 4, 5, 6, 7, 8. Done. Okay, that's 8 points. Start from the left. And each unit, they will increase by 0.5. Okay, each point will increase by 0.5. And then the width is a half. Because the rectangle you sketch is like this. Okay, that's a F2. But this is a half. So everything needs to be times by half. Okay, this half is most of the people will forget because they always think it's a 1. Okay, they always treat it as a 1. So the half is actually the width. So it's length times width. Okay, you add all the lengths together and then you times that by width. So therefore, the right endpoint will be F2.5 plus F3 plus F3.5 plus F4 plus F4.5 plus F5 plus F5.5 plus F6 and then times by a half. Okay, I use the most right hand side one but not the most left hand side one. Still 8 rectangles. And don't forget adding a half times a half. I'll just write something for you. Okay, I need to think about it. That's just something quick in the calculator. How many? Okay, you can copy this down. I'm not going to explain too much to that. I don't think it worth us to go through that like in details. But that's when you can put that on your notes. When you need it, you just directly sub values in. A, B, and N should be the values you already know. Okay, it's the given value. So A, B, and N should be given value. A and B is the interval you want to approximate the area. Okay, I want to find area in between 1 and 5. Then A is 1, B is 5. N is how many intervals I want. Okay, so I want 8 partitions. I want to 6 partitions in between A and B. So N is something how many rectangles you want, basically. H, okay, so you calculate H, like H is whatever you calculate there. So that's the width. Okay, H is equals to what? Equals to width. Okay, so I have a length of 4, but a partition of 8, so width is 0.5. So you have the width there. And then A is whatever given. For example, A is 1 to 5, A is 1, then A is 1 is exactly the same. So the left hand side is the using calculators to approximate the left hand side, and right hand side is the only difference is that 0 to n minus 1 or K is 1 to n, like it depends on that. So K is the variable you times it. I will show you that. In a calculator. Well, why I go through this? If it's only 3 or 4 rectangles, that would be easy to type into the calculator. But for example, something like that, 8 rectangles, you need to type something 8 times. It's really annoying. So that's why I go through this formula. If you have your bound reference, you can directly type that in. So for example, this question. So for this question, what I will have is A equals to 2, B equals to 6, and then H will equals to 6 minus 2 divided by 8. That is a 0.5. Like, let's write 0.5. And N equals to 8. Okay, so that's all the variables I have here. So if I want to calculate the left-hand side approximation, in the calculator, I go this place and I see this button here. Can you see this next to the matrix? I click on that one. So what I put in is K equals to 0 to n minus 1. So n minus 1 is a 7. N is 8, so it's 7. And then, sorry, forgot to define the function. What's the function? 1 over x. Control var fx. Okay, so I want that out. Then I'll put f bracket. What is a? A is 2. 2 plus h. H is a 0.5 times by k. Well, k is this here. K is the changing value. And this function needs to be times by 0.5 again, so times h. So inside is a plus h times k, and outside times another h. So that's the formula I give to you, right? That's the formula I give to you. And then press enter. That is the value you will have. Well, if you change 0.5 to half, that will give you exact value. Just don't want to change that now. Like, you can change that to half to get exact value. So that's the left-hand side approximation. If you type the long formula in, you get exactly the same thing as this one give you. And you can copy that down. Change that to 1 to 8. So that. So everything stay exactly the same. Well, I changed that to half. Wrong place. Just change that to 1 and change that to 8. Okay, so that will give you the right hand side approximation. And you can think about that. 1 over x is a shape like that. Decreasing function. Left hand side approximation will be larger than the right hand side approximation, right? left-hand side approximation should be larger than the right-hand side approximation, and my answer shows that as well. Okay, so this is, I don't think this will come up, but if something come up and you really need a long calculation, you can just copy the formula down. So that's the formula, and that's NHABK value. A K is just K, just leave K as K. That's what you can do, okay? Don't have time to complete the previous one, but 9 is a really easy one. You can just do that by yourself.